Welcome back everyone. In this video we're going to discuss triangle. Here we'll be looking into one very interesting theorem and we'll be solving some numericals. So without any further ado, let's get started. The theorem states that if two triangles are equiangular, then the ratio of the corresponding sides is same as the ratio of the corresponding medians. What do we mean by that? That means ratio of the corresponding sides, that is BC by EF is equal to AP by DQ, ratio of the medians. So this is what you have to prove. So let's do that. Given in triangle ABC and in triangle DEF, angle A equal to angle D, B, E and C equals to F. Why? Because they are equiangular. To prove this, how do we prove that? Since equiangular triangles are similar, right? We can see that all angles are equal, so we can say that by AAA they're similar. So we can simply say that since equiangular triangles are similar, triangle ABC is similar to triangle DEF. Then this is the property of the similarity, that is AB by DE is equal to BC by EF. Okay, this is our main thing. So AB by DE is equal to 2PQ by 2EQ. BC will be equal to twice of PQ because this point is your median, right? That means this is half of this, or in other words, this is twice of this, right? So 2BP, and this is also twice of this, so 2EQ. Then 2 and 2 will get cancelled. You'll get AB by DE is equal to BP by EQ. Let's mark this as equation 2 and let's mark this as equation 1. Again, in triangle ABP, so we're going to take this triangle ABP and DEQ, this triangle, AB by DE is equal to BP by EQ from 2, and angle B is equal to angle E, which is given. So by SAS similarity, we have ABP is similar to triangle DEQ. Then this is again the property of similarity. So if you compare 1 and 3, okay, that is equation 1 and equation 3 will have this is equal to this. So we have BC by EF is equal to AP by DQ. Please note that this theorem works for bisector of angles, that is if this line is the bisector of angle and not median. Also if this is the height of the triangles, that means it can be either median or bisector, or it can be the height. Let us now discuss some numericals. So the area of two similar triangles, this and this, are in the ratio 9:16. If BC is 4.5, find the length of QR. Okay, for this we'll have to know this theorem, that is the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. So since these two triangles are similar, we have ratio of the area is equal to ratio of the squares of the corresponding side. So we have BC, so it has to match with BC, QR has to match with QR. So if you substitute, it is given that this ratio is 9:16, so 9 by 16, and BC is 4.5 square and QR is QR, we'll have to find that, and QR square will be equal to this if you cross multiply. So QR will be square root of this, so square root of this means it will be 4.5, and 16 will become 4, 9 will become 3, and if you solve this you get 6 centimeter. Please note this is very important. Let us see another similar question. The areas of two similar triangles are this and this. So here instead of ratios the areas are given. If the median of the first triangle is this much, then the corresponding median of the other is, you'll have to find. Let these two triangles be similar. Since the triangle name is not given, let us name them, it becomes easier. And AB is equal to this centimeter. Therefore this is what we know, right? Ratio of the areas is equal to square of the ratio of the corresponding side. So here, since they are median, we will write the same thing, but instead of sides we will be writing median. Okay, so you'll have to copy the same thing. So here we know that this is 121 and this is 64 and this is this. So if you cross multiply you get D square is equal to this, and D will become square root of this. So if you cancel you will get 8.8 centimeter. This is simple calculation, so I have omitted it. if ABC and BDE triangles are equilateral triangles where D is the midpoint of BC, find the ratio of the areas of ABC and BD. So if you have to draw the figure, this is how it looked. ABC, D is the midpoint. Okay, this is an equilateral triangle, means all sides are equal, and here also all sides are equal. Now how do you do this question? It's very simple. Since these two triangles are equilateral triangles, that means all angles are 60 degree, right? Therefore this is similar to this. You can write here by AA similarity. Therefore ratio of their areas should be equal to the ratio of the squares of the corresponding sides. So this sentence you'll have to memorize. Then area of this by this will be equal to, now BC, if you look at BC, it will be equal to twice of BD, since D is the midpoint. So you can substitute twice BD by BD square will remain as BD square. Then you can cancel this square and BD square, so you'll get 2 square, which is 4. So 4 by 1. Therefore the ratio of the areas of the triangle is 4:1. Let's see the next question. Equilateral triangles are drawn on the sides of right triangle. Show that the sum of areas of the triangle on the other two sides is equal to the area of the triangle on the hypotenuse. So this is how it will look. So this is your right angle triangle, that is ABC, and equilateral triangles are drawn on this side, and on this side. You'll have to show that sum of the squares of this two is equal to this. So let triangle ABC be the right angle triangle, and this two be the equilateral triangles drawn on the side. Okay, so this is the right angle triangle and these are the equilateral triangles drawn on the side. To show area of BPC plus BPQ is equal to this, that's what you'll have to prove, right? Sum of the areas of this two is equal to this. So we'll take the left hand side. Now left hand side is this. Now we know that area of equilateral triangle is √3 by 4 side square. Similarly here, so side here is BC for this triangle, and side here is AB for this triangle. So it'll become √3 by 4. If you take common, you get BC square plus AB square. Now we know that BC square plus AB square is AC square by Pythagoras theorem. Okay, so it should be AC square. So right hand side is equal to area of triangle ARC, so which is nothing but √3/4 by AC square, which is nothing but your left hand side. So proved. Let us see one more question. If D is a midpoint on the side AB of triangle ABC such that AD is to DB is equal to 3:2, and E is the point on BC such that DE is parallel to AC, find the ratio of this two triangle. Okay, so given that AD by DB is equal to 3/2, that is what it is given, right? The ratio. So let AD be 3x. So what we do, we take AD to be 3x and DB to be 2x. Also these two are parallel, that is also given. So we'll prove that these two triangles are similar. So it's very easy. This triangle is equal, this angle is equal to this angle, and this angle is common. So we have that these two triangles are similar. Now we know that if two triangles are similar, the ratio of their areas is equal to the ratio of the squares of the corresponding side. So you'll have to write that sentence as we have seen in the previous question. So you'll have to find this ratio. So if you substitute this BD, from here it is 2x, so this is 2x, and AB is nothing but this plus this. So AD is 3x and BD is 2x, so 3x plus 2x, which is nothing but 5x. So x square and x square will get cancelled. 2 square is 4, 5 square is 25. So the ratio of triangle ABC is to BD is 25/4. Since in the question this is given first, so we'll write ABC first. Okay, you can do this whole question with this on top and this at the bottom, just to satisfy the question. With this, we come to an end of our video. Please practice as many questions from this exercise as possible, and if you have any queries, please drop it in the comment box. So thank you everyone for watching. I hope to see you in my next video. Take care everyone.